What's up, guys? This will be lesson 5 of Crypto Zombies, and in this video we're going to be talking about crypto collectibles. You probably know them as NFTs or non-fungible tokens, and you'll also come to know them as ERC-721 tokens. Now, if you're familiar with Ethereum, you're probably familiar with the currencies that are kind of built on top of Ethereum, and those currencies are really just ERC-20 tokens. Now, ERC-20 tokens are really just smart contracts that follow some common rules built on top of Ethereum. Here are a couple of those rules for ERC-20 tokens. We don't really want to focus too much on ERC-20 tokens because they behave like currencies. Now, in this video, what we want to do is we want to add a collectible component to our smart contract, not a currency component. We want our zombies to be unique and interchangeable, and they need to be interchangeable in like a whole fashion, right? So you'll notice like with these currencies, you can, there's like some decimals and stuff like that, right? Like I could send you like a half of an Ethereum or 0.237 Ethereum, but I can't really send you 0.237 of a zombie, right? Like that wouldn't make sense, right? Of like a collectible. So what we're going to do is we're going to implement a different spec called an ERC-721. Now, ERC-721 tokens are not interchangeable since each one is assumed to be unique. They're not divisible. You can only trade them in whole units, and each one has a unique ID. So these are a perfect fit for making our zombies tradable. All right, so let's put this to the test. You can kind of, if you want, you can read over more of this documentation here and read over this stuff, but we mostly want to focus on the code in this video. All right, so let's put this to the test. First thing is going to be the pragma. So I'm just going to literally lift this from there just so I don't have to type it out. All right, next thing we're going to do is import zombie attack since we're going to be inheriting from it. So zombie attack.sol, we actually need this since it's in the same directory, and we'll end it with a semicolon. Next thing we're going to do is declare contract. So contract zombie ownership like that, and is, because it's going to inherit from, zombie attack. Let's change that to that to that. All right, and we're just going to leave the contract empty for now and fill it in the next chapters. All right, so this is the ERC-721 standard, and we're also going to be talking about multiple inheritance in Solidity. So we do have multiple inheritance in Solidity, which is nice. Some languages don't have that. I don't think Java has multiple inheritance. I can't remember. Anyway, so here are what you need to be an ERC-721 token or an NFT, right? So here's what we need. We have these events for transfer and approval. Then we have 4 functions that we need to implement. One is balance of, so we know basically, what NFTs, I guess, do we have? What is the owner of for this particular like NFT? Transferring NFTs or collectibles or whatever, and approving a transfer, which is something you might want to do. If you're the owner, you say like, okay, I approve that you take my zombie, and then the guy who, like the separate guy who you're sending it to, can now call transfer from. So you could call transfer from yourself to send it to him. If he tried to call transfer from, first you'd have to approve that he can do that, and then he can transfer from your address and take it for himself. So that's kind of what this approve method here is for, just so we can say, hey, you can take this collectible if you want it, right? All right, so implementing a token contract. So when we do this, and we've done this before, basically like we've done with the ownable.sol, we're going to do the same thing with this ERC-721.sol. Now, before we kind of implement that, first they're going to just talk about multiple inheritance here. We have a few, names and stuff like that. So we're saying like Satoshi Nakamoto. Satoshi Nakamoto is the guy who made Bitcoin, and a lot of people think he is maybe multiple people, right? So this, I think what this contract here is implying is that it's both Nick Szabo and Hal Finney. So anyway, this is just a way to tell you that Solidity has multiple inheritance. All right. Now let's do that. So did they already import? No. So we're going to have to import ERC 721. I always forget to put this / in the front. .sol. Okay. And now the next thing we're going to do is we're already inheriting from zombie attack. Now we're also going to inherit from ERC 721. Okay, so now we have all of the methods and things from zombie attack, and we also have ERC 721. And maybe I'll take a look at this first just so you can see. Remember this code up here? That's all we have right here. So it's just a bunch of method signatures that we're going to end up actually implementing. All right. Okay, let's check the answer. All right, so the first two that we're going to implement are balance of and owner of. So let's dive into the implementation. Let's see, we've gone ahead and copied the empty shell functions. So you can see, like, all right, they already copied our functions for us here. And they don't do anything yet, so we're going to actually fill in the blanks for balance of and owner of. So this is, you know, I guess how many of the NFTs do you have, and who's the owner of the NFT. All right. This one just, I guess, I mean, it's pretty obvious. This one takes an address for the owner, and this one takes the token ID and returns back who owns it. All right. So let's see, I'll leave it to you to figure out how to implement these two functions. So I guess you could try it before I do it. Each function should simply be one line of code after a return statement. And so basically we have code that's kind of done this before, so we can do that. So let's do implement balance of to return the number of zombies the owner has. So where can we get that from? So let's do return. And where can we put an address in and get the number of zombies out? So if you remember from the first lesson, we have a mapping for that. So we have, let's see, owner zombie count, right? So what does that take? It takes an address. So let's do this, return, I think it was owner zombie count, something like that, right? And actually it takes it like this, and we need owner. Okay, and that should return us the count for the address that was passed. Now we have the exact mapping that we're going to need right above that for zombie to owner. So what does this do? It says owner of. Now this is the zombie, which is the token ID, and it's going to return an address, which is the owner of that token. So let's just do another return here, and we could probably just copy this. So I think it's zombie to owner. All right. And what's it take? It takes that token ID. Token ID. All right. And that should be it. Okay. So also we're going to have to do some refactoring here. Now you may have noticed from the last lesson here that we implemented something called owner of for our function. Now that's kind of an issue because, as we're going to kind of talk about here, we created a modifier called owner of in the last, I think the last video or the video before that, I can't remember. So we can't have a modifier and a function be the same name. Now we created that modifier, so it's better to change that because we cannot change any of the names here. So like you can't make this owner of like 1 or something like that. I can't edit this, but like you can't make this whatever you want. Otherwise the contract won't be valid. All right. So what we're going to do is we're just going to change our modifier. So we're back in zombie feeding.sol, and we're going to change the name of our modifier to owner, from owner of to only owner of. All right. So we need to go in here and do only owner of. And then also we're going to need to update that here. And I put a B. Only owner of. All right. And that should be all I think they ask us to do here. They will note that they did change this in zombiehelper.sol and zombieattack.sol for us, but they don't really want us to, spend too much time refactoring everything. It's just kind of to reinforce the idea that you can't rename any of this stuff. It has to be these exact names for it to implement and be an ERC721 token. All right, so chapter 5. Transfer logic. So how can I transfer a zombie from me to somebody else? Because collectibles are no fun if you're the only one who can own them. There has to be at least this idea that you could send them to somebody else, right? So that somebody else could own, whatever it is. So let's see. We have two different ways to transfer tokens. Now this is a little bit confusing, but it's all in how you want to do the transfer. Now this transfer method is I own the zombie and I'm transferring it to you. So there's no approval that needs to happen there because I'm the guy who owns the zombie. It's no problem, right? And then there's also this concept of approval and then transfer. So this approval is me approving and then you running the transfer from logic, right? So first I'm going to approve, and then you're going to run the transfer from logic yourself. And then you can just take the collectible from me after I've approved that. So that's what they're kind of going into here, but that's a little bit confusing. So just kind of think about how you would be swapping these things or transferring. Let's see. So same transfer logic, approve, yeah. And they're just talking about how we're going to create the function here. All right, so let's define a function called transfer. Okay, so function, I think this is private, so transfer. And this is going to take 3 arguments. So we have address from, we have address to, and we have unsigned integer 256. Now I think we have to do that. I'm not really sure why we actually have to type out 256 since regular unsigned integers are 256. I'm assuming they talk about it somewhere up here, but I'm sure there's some good reason for that. Okay, so we have that, and that will be token ID. Token ID. All right. This method or function here will be private, and that should be that. Now we have 2 mappings that will change when ownership changes. Owner zombie count, which keeps track of how many zombies an owner has, and zombie to owner, which keeps track of who owns what. All right. So the first thing our function should do is increment owner zombie count for the person receiving the zombie, which is address 2, and we'll just use plus to increment. So let's see. So we have 2 mappings. Let's see. So we have owner zombie count. So owner zombie count. And I think we're going to need to take that from, let's see, or maybe it'll be 2. Let's see, with 2 mapping that changes owner zombie count, which yeah, that has to be decrement, and zombie to owner, which keeps track of who owns what. First thing our function should do is increment owner zombie count for the person receiving it. Yeah, so we need to put that as 2. So that'll be plus. Okay. Next, we'll need to decrement owner zombie count from. So we'll just take this here, and so because it's coming from him, he's losing 1 zombie. Okay. And lastly, we'll want to change zombie to owner to have the mapping for 2, which is the address it's going to, right? So it used to be this address, now to be this address. So let's implement that here. We need zombie to owner, and that's going to take, let's see, 2. Our zombie to owner will be, actually that thing takes in, we can always check too. Well, actually we have it up here, zombie to owner. It takes in a token ID. So we pass the token ID, and the owner will now be 2. Okay, so that should be that part. Now that apparently wasn't the last step. The ERC20 spec includes a transfer event on the last line that should fire when we pass the correct information, blah, 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 blah. So it needs some arguments, and we can check there. So we're going to need to emit an event. So emit a transfer has happened. We'll just type it out here. Okay. And so what do we need for a transfer emission? So we need the address from, to, and the token ID. All right, so let's put that in. So that will be from, to, and the token ID. Okay, and that should be it. Let's see what I messed up. We have a capital D there. All right. Now, this is going to be just the transfer continued. So we have our little private function here, which we're going to be using like internally as a utility function. But this function is external and payable. So this function is the one that will be called from another contract or by someone else. All right. So apparently that was the difficult part, but we'll see. Let's see. So we already have a transfer function that does pretty much all the heavy lifting of doing the actual transfer. So we're going to implement our the method that they'll be calling. So first we want to make sure only the owner or the approved address of a token zombie can transfer it. So let's see, let's define a mapping called zombie approvals. So I guess that's what we're doing up here. So mapping, and sometimes I forget what that looks like. Whoops, let's go here. Okay, so it'll look something like that to that. Okay, and so this, now what does this have? Zombie approvals. It should map a uint, so an unsigned integer, to an address. Okay, and this way when someone that is not the owner calls transfer from with a token ID, we can use this mapping to quickly look up if it's approved. So this will be for, remember, if we run that approval step first. Okay, so next let's add a require statement. All right, so we're actually going to want to name this first though. This will be zombie approvals, like that, I think. All right. And next we're going to add our require statement. So let's see, we're going to do require, and what will we need to require? Probably that the person needs to either be in zombie approvals or message.sender is equal to whoever, right? So let's see. So next add the requirement statement, our require statement to transfer from. It should make sure that only the owner or the approved address of the token can transfer it. Okay. And then also we're going to need to call transfer. So I think calling transfer, we'll do that last, I guess. All right, so note checking that only the owner of the approved address or the zombie can transfer. It means that at least one of these conditions must be true. Zombie to owner for token ID is equal to message.sender. So we'll do that first. So zombie to owner of token ID is equal to message.sender, or zombie approvals of token ID is equal to message.sender, right? So this is the case that there is an approval needed to happen, or an approval happened first and someone else is now calling this method who we have approved. That's what this other piece of logic here is for. So we're also going to pass token ID there, and we're going to say if that's equal to message.sender. Okay, and remember, message.sender is just the address calling the smart contract. All right, so let's call our transfer function, and we know what it takes. So because it's right above us there, and I'm pretty sure all of the same names are here. So to, from, to, and token ID. All right, and let's see if I mess some syntax up or something. Nope. All right, cool. So now we're going to go over the approve logic. So remember that with an approve, the transfer happens in 2 steps. So this is where I approve somebody else can take my zombie or whatever, and then they go ahead and run the transfer logic. Okay, so yep, just explaining that. So yep, okay. 2 function calls, and we'll need to use the zombie's approval data in order to make this work. Okay, so let's put it to the test. In the approve function, we want to make sure that only the owner of the token can give someone approval to take it. So we need to use the only owner of modifier, which we created before. So only the owner of the zombie can approve a transfer. Okay, so we're going to need only owner of. Okay, and I forget where we actually put that in, because I know it takes something. It might not take anything, but let's be sure. So we have only owner of, and what that actually takes is the zombie ID. So we will need to pass the zombie ID. In this case, that will be the token ID, I'm pretty sure. Because remember, now our token is our zombie. Okay, so token ID, like that. And now we will be defining the rest of the function here. So for the body of the function, set zombie approvals for token ID equal to the approved address. All right, so let's do that. So zombie approvals, token ID is going to be, equal to approved. Okay, and so what this is going to do is it's going to say for this token, this address is approved, and we're going to add it to this mapping, and this is on the blockchain. All right, so that should work. All right, so chapter 8, I guess we're almost done with the approve method here. So we're also going to need to fire the approval or emit the approval event. Okay, so this is just letting our front end know, or whoever needs to know, that a approval happened on the blockchain for this. So approval, like that. Okay, and what does it take? Let's see. An approval takes an owner, the approved, and the token ID. All right, so who is the owner? The owner should be, I think, message.sender. And then we have approved, and then we have the token ID. Okay, and yeah, they do say message.sender is the owner. What did I mess up here? Approval, blah, 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 message.sender, approved, token ID. I don't know, that looks good to me. I don't see any problems. I'm sure it's something small. Let's see. Oh, yeah. We need to emit that event. We can't just call approval. That wouldn't make sense. And we can see from our transfer event here that we do need to emit for the event to show up. All right. All right, so preventing overflows. So this is kind of interesting, and it's kind of going to be talking about like bit manipulation and why we would want to implement kind of a different kind of math, right? So like what we're using when we're just doing like regular math in Solidity is kind of like dumb math. It'll allow for some, you know, kind of undesirable you know, math or overflows to happen, and so we don't want that, right? So, or also, I think I don't know if we're going to handle that, but this is like another check in which like maybe you don't want to be able to even be able to send your zombie to address 0, which would just be burning it, right? So you would be getting rid of that collectible on purpose, right? So you might not want to even be able to do that. So maybe some people could stop that. And there might be a million things that you kind of want to check and make sure can't happen on your smart contract, so that either a bug won't be, you know, written to the smart contract for eternity, or a hacker can't come in and maybe steal something in some way by doing some weird overflow logic. So let's talk about what an overflow is. If we implement a uint8 here, so a uint8, right, only has this many places, essentially, like in a binary number, right? So it can only be 1 8 times, right? So that's 2 to the 8 minus 1, because remember, like 0 place, so we're talking 0 to 255. And so if we go to 256, what do you think will happen? So what will have to happen is that we're going to try and add another 1, and all of these will go to 0, and then we'll try to add a 1 after that, right? What will actually happen though is we only have 8 places, so everything will just be 0, and then when we do plus plus after 255, we'll just get 0. And so that's kind of trouble, right? So instead of doing that, we want to do safe math. And so we're going to implement a library called safe math and make sure that we can't overflow and that we just end up getting an error if we try to overflow. Let's see. I think that's basically all we're going to talk about. So really, like, instead of just doing like plus, you're going to do dot add, and then you're going to pass the number that you want to add. All right. And I guess this is OpenZeppelin's safe math library. OpenZeppelin seems to have a lot of good stuff. And so let's actually implement it. All right, so we're going to do import safemath.sol. All right, and the next thing we're going to do is declare that we're using it. So using safe math for uint 250, I guess we just said 32 there, but 256. All right, so we're going to be using it for unsigned integers 256. So that's all it'll be, you know, that's all it'll really work for, I guess, right now. And I think that's all they want us to do right now. And we're actually going to be implementing that in later chapters. All right, so safe math part 2. Let's take a look at the code behind safe math. So let's see. All right, we have 2 numbers coming in. We have a and b. If a is 0, just return 0. This is for multiplication. So and then we also do some assertions like c divided by a can't equal b. So I'll let you go and check out all the math here. But you know, this is essentially just doing checks that, like, if this assertion fails, right, if like this is not the case, then you did an invalid mathematical operation. And what'll happen on an assert is basically all of the gas that was spent when it reaches this assert will have gone through and you won't be refunded anything. And really, we hope to never fail on an assert. It's like something really bad happened, and you know, it's ultimately you should never reach here if possible, right? But it's better that we fail the operation on the blockchain than even let it go through incorrectly, because if it went through incorrectly, it would really ruin the functionality versus just ruin you know, one small corner case or something like that, which this assert is preventing. Okay, so let's I mean, they're just kind of go over like all the stuff here, which is like, you know, making sure all of this stuff makes sense. Like, for instance, like C can't be greater than A, or assert that C has to be greater than A after adding A to B, right? Like, how could you have a smaller result after adding A and B, right? Okay, so let's use it in our code. So instead of doing this increment operator, we're actually going to do it like this. All right, so we're going to need to do this equals, because we can't do it in just kind of one cool line anymore. So we'll copy that, do this, and dot add, and 1. And we'll do that same thing with this. This is probably going to get pretty tedious as we do it for all of our increments. Dot sub 1. All right, I think that's all they need us to change here. All right, so part 3, we're going to be doing this for not only 256, but also for 32s and 16s, because you notice that we have 32s and 16s here for level and ready time, and also win count and loss count. So I think we could actually just take this like this, because we're lazy, just like that, and just like this. All right, and now what we'll do is, instead of using these pluses, I guess they also, by the way, we're not even going to bother, I guess, with this. So we chose not to prevent the year 2038 problem, so we don't need to worry about overflows. You know, like we kind of talked about before, your app is basically screwed in 2038 anyway, because we decided to use unsigned integer 32 here, but you don't really have to worry about that. All right, so let's do this. Equals. Copy this. Okay. Whoops. Dot add 1. All right, I think that should be it. And now we're going to do it with a couple other things. So let's see. Here's one here. So rand nonce equals that. So we'll do rand nonce dot add 1. Here's 3 more here. So we're going to need to do this equals. Grab this. All right, dot add 1. I'm so glad that they didn't just do this for me. So now that I get to type it all out, add 1. And we need to do this one more time here. Equals add 1. Okay. Hopefully I didn't have to subtract anything there. All right, and these are 2 more. So equals loss count, add 1, and same thing with this one. Dot add 1. All right. All right, so now that's over. I guess briefly we're going to talk about comments here, and that's pretty much it though. Like, we've basically already implemented everything. We're just going to talk about comments, and then we'll kind of, see how this works. All right, so the Solidity code for the game, the zombie game, is finally finished. So that's really all the smart contract stuff you're going to have to do. The video after this one will focus on Web3 and essentially like the front end aspect for our smart contract and how to interact with it. All right, and so let's talk about commenting, I guess. If you're interested, you've probably seen comments, like all over the code before, and you probably understand what comments are. I guess there's some other interesting stuff with comments, which is like multi-line comments, which is just, like as simple as this, and see how it commented everything out like that. If we do this, then there you go, and you can put some comments in between here. All right, and I guess you also have some other things that will, let's see, guess it's good practice, blah, 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 quickly understand, NatSpec, which looks like this. Okay, so I guess there's some NatSpec. This is something I'm not really aware of, but if you want to, I guess at the top of your contract, which is probably a good idea, and you should definitely do this, and I'm sure it's used in some metadata somewhere, that if you put 3 comments here and you do @title, like that, and then you say what it is, and then you can do the same thing for your author. I wonder if these emojis will copy and paste. Yep. And also a notice. So, maybe some notice about how it works. All right, so I don't think that really matters if they really check. I guess they do check. Let's get rid of this. Try again. All right. Okay, so wrapping up. That was weird. They all kind of had to show up weird. Okay. As a reward, we transferred your very own level 10. I don't know who Haxfield Morris is. This is a meme that I guess I don't understand. Now you have 4 zombies in your army. I guess these are all the zombies in my army here. And before we move on, the option to rename any of them. I don't really care about renaming them, I guess. And let's recap really fast. So tokens, the ERC 721 standard, and tradable assets and zombies. That's something we learned in this video. Libraries and how to use libraries like the Safe Math library. How to prevent overflows and underflows using that Safe Math library and why you might want to do that. And then also, I guess the last thing we learned, which is, I guess usually the first thing you learned is how to comment, but what we learned is how to comment with the NatSpec standard, which I guess is important for metadata on your smart contract. This is basically all we had to do for Solidity code. I guess maybe they'll do more in the future, but basically this is all we had to do for that. The next video, I guess, will just be like Web3. I guess they say in the next 2 lessons, but I don't know if there's 2 lessons after this. I feel like there's just 1. All right, so let's go to the next thing here. This is our Haxfield Morris, and we'll just tweet this out, I guess. Whoops. All right, just like that. All right, and that's pretty much the end of this video, so I'm just going to go over where you can find me online, and then it'll pretty much be over. So this is my website. You can find all my social media here, and check out whatever you want. I would rather you follow me on Odyssey rather than YouTube. You're most likely watching this on YouTube, but I would rather you be watching this over on Odyssey. You can follow my GitHub page. This has all my projects and stuff like that if you're interested in some of the other stuff I'm doing. You can subscribe to me or follow me or whatever over on Twitter. I don't post much. I'm not going to really spam you with anything. If you want to support the channel and you like what I'm doing, you can help support me over on Patreon. I would really appreciate it. If I stream on Twitch and YouTube, so that happens rarely, but I guess it happens. And also, if you need help with anything or you just want to talk about crypto, I guess this guy's asking about blockchain stuff, but we talk about all kinds of things in the Discord and Matrix channel. I'd rather you really join the Matrix than Discord, but most people use Discord, so you can check this out too. And that's pretty much it for this video. I'll see you guys in the next one.